Welcome to Kinetic Molecular Theory. This concept helps us understand how gases behave at the molecular level, revealing the connection between invisible particles and the properties we observe every day. Kinetic molecular theory is a scientific model that describes gases as made up of countless tiny particles. These particles move constantly and randomly, and their behavior explains much of what we see when we study gases. The first postulate states that gases consist of small particles whose individual volume is negligible compared to the entire container. The second postulate tells us these particles are always moving quickly and in random directions. The third postulate describes gas collisions. When particles hit the walls of the container or each other, there is no loss of energy. Their collisions are perfectly elastic. The fourth postulate states that gas particles do not attract or repel each other. There are no forces acting between them. The fifth postulate says the average kinetic energy of gas particles depends directly on the absolute temperature. In other words, if temperature increases, particles move faster because their kinetic energy goes up proportionally. Kinetic molecular theory helps us understand several important properties of gases. Gas pressure is caused by particles colliding with the walls of the container. Temperature is a measure of the average speed and energy of these moving particles. Expansion happens because gas particles spread out to fill any space available. Diffusion occurs as random particle motion causes gases to mix and spread evenly. An ideal gas would follow all the postulates of kinetic molecular theory perfectly, with particles having no volume and no attraction between them. Real gases behave almost like ideal gases under ordinary conditions, but show differences when pressure is very high or temperature is very low. Real gas particles do have some volume and experience weak attractions, causing deviations from ideal behavior. Kinetic molecular theory gives us a microscopic explanation for gas behavior. Gas particles are always in motion, and their individual volume is tiny compared to the container. Temperature reflects how much kinetic energy the particles have. Under extreme conditions, real gases do not behave exactly like ideal gases, showing differences that are important in science and technology.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.